In this video, we're finishing up finding angle measures formed with parallel and perpendicular lines. I just wanted to make sure that we have talked about this notation before. So if we look at this diagram down here, we have some notation here I want to make sure we can recognize. We'll come back and look at these theorems in just a minute, but this notation tells us J is perpendicular to H. We would if we were to write that out, we would say line J is perpendicular to line H. Notice both of these use lowercase letters to name our lines because we only have one letter. So line J here, line H are perpendicular. They're shown with this right angle symbol here. This is a symbol or a notation for parallel lines. Line H is parallel to line K. That's how we would write it out. Line H is parallel to line K. And you'll notice the notation we use here are little arrows showing that they're parallel to each other. So if we had other lines we wanted to show were parallel, we could use two sets of arrows to show that these two are parallel to each other and these two are parallel to each other. But these aren't necessarily parallel. Up here, obviously they're going to intersect. Just want to make sure that notation was clear. These theorems we're going to look at next deal a lot with those notations. The first theorem is the linear pair perpendicular theorem. It says if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So notice the key here is that the lines intersect to form a linear pair of congruent angles. If angle 1 and angle 2 are congruent, we already know linear pairs add up to 180 degrees, so if it's the same thing adding up to 180 degrees, the only thing that can add up to 180 degrees plus itself would be 90. So 90 and 90 is 180. So because these both have to be 90 degrees, that makes these lines perpendicular to each other. That's the linear pair perpendicular theorem. The next theorem we're going to look at is called perpendicular transversal theorem. It says in a plane, if a transversal is perpendicular to one of two parallel lines, then it is also perpendicular to the other line. Here's an example. Oops, this should say parallel. Sorry about that misnotation. Because we know that J is perpendicular to H, and we're also told that H and K are parallel lines, that means that J has to be perpendicular to K. If we think about it, we have parallel lines here. These are corresponding angles. Corresponding angles have to be congruent when we have parallel lines, so this also would have to be a right angle to show that it's also 90 degrees. The last one we're going to look at is lines perpendicular to a transversal theorem. So we should recognize these terms here. We know perpendicular means they meet at a right angle. We recognize a transversal as a line cutting two or more lines. So we're said in a plane, if two lines are perpendicular to the same line, so notice that N is perpendicular to P and M is also perpendicular to P, then they must be parallel to each other. So here M and N are parallel to each other. Again, the notation is two lines there. Sorry, my symbols didn't print off correctly. So we're going to look at some examples where we'll use those theorems. This one asks us to determine which, if any, lines must be parallel and explain. If we look here, we have a theorem that says if one is perpendicular to, here's the theorem. If one is perpendicular to parallel lines, then they must be perpendicular to both. That's not the example we have here. We don't know if these are parallel. We're trying to see if we can prove they're parallel. This line is perpendicular. We can't change that. There's nothing about this line that we know. So there's nothing saying that this line couldn't be coming through at an angle instead, which would obviously not be parallel to P. So there's not enough information on number 5. If we look at number 6, we see here that these two lines are both perpendicular to line R. Because these two lines are perpendicular to line R, it matches our description up here of the line perpendicular to the transversal theorem, which says if two lines are perpendicular to the same line, then they are parallel to each other. Notice this starts out by saying in a plane. That just means we can't have lines on different planes parallel. They may not even intersect each other. So if you think about a line on the front wall of your classroom and the line on the back wall of your classroom, they could be parallel to each other, but if they're not in the same plane, then this rule doesn't apply. But here they're all in the same plane. They're all in our picture. There's no lines showing us there's different planes going on here, and this is a flat surface. So because they're perpendicular to the same lines, they must be parallel to each other. That is lines P and Q, and our reason was lines perpendicular to a transversal transversal theorem. We don't know anything about line S though, so we can't jump to conclusions we don't know. So that's all we can answer for number 6. If you would, take a minute and look through the independent practice. Go ahead and pause the video now to do that, and then if you need help, you can look at a couple of hints I've given you. Okay, so here's what it's asking for on question number 1. Find the measure of each angle and tell why. So we should be able to say measure of angle 1 equals some degrees measure, and the reason why would be something like corresponding angles, alternate interior angles, vertical angles, alternate exterior angles, or consecutive interior angles, same side interior angles. That's going to be our reason here. We have those theorems that tell us different things. Same thing for number 2. On number 2, I tried to help you out a little bit more. We know because corresponding angles are congruent when we have parallel lines that the measure of angle 6 must be 52. So we can substitute in and say, okay, 4x plus 52 equals 180 because these two angles are a linear pair. And then we can subtract to get 4x by itself, divide to get x by itself, and you should be able to solve that from there. Lastly, if you're stuck on number 3, we're asked to determine which, if any, lines must be parallel. So N is perpendicular to S. We know that by the linear pair perpendicular theorem. That means that these two are both perpendicular to line S. M and N must be parallel. S and T must be parallel because they are both perpendicular to line N. I'd like to still see what those two reasons are. So these are part of your answer. I want to see how you know those are. I told you up here because they're perpendicular to line, I want you to tell me what those theorems are. Whoops, sorry. So once you finish that, you'll be ready for your teacher talk.